Hello, 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 folks. Thanks for coming on by. Advent of Code, day 13, in less than 15 seconds. Got my code up, my Quaco ready, screencasting is on, consoles are ready to log, and here we go. Oh, that's a little terrifying. Indices. Ooh, it's a big input, too. Don't hang in there, Firefox. We believe in you. Ooh, how terrifying. Yowza. Oh, wow, okay. Jason was like, I got it. No, you don't. You don't. Okay. Blah, blah, blah. For example, this is a terrifying example. Do. So we got some spaces or some lines delimiting these, so that's a good sign. Packet data consists of listed integers. Each starts with a thing, ends with a thing, contains zero more comma separated values. Blah, 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 blah. Comparing two values, the first is left, the second is right. Then, if both are integers, the lower come first. If both are lists, compare first of each, then second of each. If left runs out of item, the inputs in right order. If right runs out of item, inputs in not right order. If lists are same length, then no comparison. Makes the decision about the order. Okay, so one side is this is a rule checking. If one is an integer, convert the integer to a list. Continue the integer's only value. Retry. If 0, 0, 0, and 2. 0 and 2, the result was found by comparing 0 and 2. Okay. 1 to 1, 3 to 3, 3 to 5, left is smaller, inputs are in right order. 1 to 4 versus 1, 4, 1 to 1, 1 to 1. Mixed types, convert right to 4, 2 to 4. Left side is smaller. Okay. As it's recursive checks. 3, 4, 5, 6. Great. What are the indexes of the pairs are already in the right order? The first pair is index 1, second 2, and the above, the pairs, the sum of the indexes is 13. Fun part now, here we go. So, it's going to be 4, so basically let good equals an array for let I. Oh, I can do this for const I line of data split new line, this dot entries. Thank you. Then if I have I, that's my number. Great. No, we don't want that. So for line, we want to parse out all of the things. Essentially, we want to convert all of these to numbers. Yeah, we want to. Can we JSON parse the whole thing? I don't see why we can't JSON parse it. Const data equals JSON.parse line. We'll have a good thing here. We'll call this line data. Sure. And then we're going to basically check if good, but this is where the recursion kicks in. So this is where the function of check thing, and what I'm returning is exactly 1. Makes a decision, continue checking the next part of the input. First is left. If both the lower come first, if first is lower than the right, inputs in the right order. If the left is higher than the right, they're not in the right order. So basically I check if they're higher. Okay, so cute little function. Function is right order. I imagine part 2 is going to be actually ordering these things. An array of any. There you go. So technically we're comparing 2 of these, so 1 array and then 2 any. How does this work on the initial thing? Let's look at 9. Oh, I see it. There you go. For each thing you split by a double new line. Got it. They're 2 separate arrays. Double new line, and then I want to map lines is lines dot split new line. We want to do this to each, so map raw, and then here JSON parse raw. There we go. This is 1, 2, and this is where we start passing away. Drop no lock. There we go. If is in right order. 1, 2, good push I. Perfect. So indexes, first, what's up if there are different lengths? I guess I don't really do anything. Are they ever different lengths? This one's different lengths. How do you do with that? There, compare, there we go. Left side random items input are in the right order. Ah, it's not always length. Hey, I appreciate that, Madeline of Trivia. I will try. So unfortunately, the lengths don't matter. It's the index. So let index equals 0. Then it's going to be while true const left equals 1 index, right equals 1 index. Now we have to do the logic here. If the left list runs out of items first, the inputs are in right order. If left triple equals undefined, return true. Good. The right list runs out of items, input are not in right order. If else, if right equals undefined, you failed. Return false. You are not good. Otherwise, if both are integers, if one is integer, great. So if type of left equals number, and, so we're going to do both easy here. And, I said and, type of right is number, return, well, don't return. Also, we don't return true, I mean, these are returns, yeah, so these ones will be continuation. If left is greater than right, so let's check this. If the left is lower than the right, inputs are in right order. So if right is greater than left, turn false, you have failed. Now for the other ones. If 1 is an integer, so if type of left equals number, then by the exclusionary whatever, then right's not a number. So right equals an array of right. Congratulations, you just became a let. I imagine this might need to actually be transformative, so that is exactly what I will do. 2 index equals right. Congratulations on the upgrade. Same logic for the else if. Else, if that one, congratulations on your left. You get the upgrade, you get the upgrade, everyone gets an upgrade. Upgrades all around. Now the fun part, then we start if is right order, left, right. Move forward. Otherwise, return false. Do I have any other continues in here? Because I'm while true, aka infinite loop. Apparently, oh, there we go. If right's a number, then left is the other one out. There we go. Choose not 13. Return. Good. Reduce. Thank you. 17, not 13. Great. So which indexes do I think are good, that are not good? 2, 3, 5, 7. The first pair has index 1. The second pair is index 2. 1, 2, 4, 6. 1, 2, 4, 6. Wait a minute. The first pair has index 1. Well, okay, firstly, math is off. So, plus plus, not plus plus, plus 1. Huh. Which ones do I think are good? Oh, this is so helpful. Super helpful. 1 and 2. Great, that's... Okay, so I think 9 and 876 are good. That's actually, they're not good. So I think they're not good. Okay, so first one, then we're gonna... Great, you didn't even make it past 1. Sad freak. Oh, excuse me. So is not right order. So we got to here. So we are checking on console log 1, 2. Congratulations. So I try 1, 1, 3, 1, 1, 1, 1, 5, 1, 1, and then I do 1 and 1. Well, that didn't go right. Oh, oops, all the oopsies. So yeah, if you're good, then move on. Move on. Go away. Be gone. Oh, don't forget the index. Please don't forget about the index. Oh, I gotta make sure, okay, I see what's going on here. If left is under, okay, that technically works, so we go through these, great, and then we console log left. I can feel an infinite loop running under my feet. Okay, we made it to 3 and 5. If right is greater than left, that is true. Left side is smaller. Whoops-a-daisy, I got it the wrong way around. Oh no. 14's not equal to 13. Now which ones? Why you know log? Log. Why you know log? Log. Why log? Come on, log down you. Now you show up. 1, 3, 4, 6. 1, 3, 1, 2, 4, 6. 1, 3, 4, 6. Okay, so apparently I think one. Yeah. 9. 1, 3, 4, 6. So I think this one's okay, but I don't think 2 is okay. So 9, 8, 7, 6. 9 versus 8, 7, 6. Convert this to 9. Right is smaller. Inputs are not in right order. I'm okay. Inputs are not in right order. Interesting. Okay, let's figure this out. I have to only look on I of 3. Continue. Thank you very much. Time for some logins. Yep, 9. Whoop. When did that happen? You didn't do that. So left is right. Neither of these are undefined. They're both not a number. Left type is number. True. So right becomes this. 2 index equals right. And then we check if in right order. Log left right. Ooh, I see what happened. You did the wrong one. If left is a number, then left becomes an array. Dagnabbit. Yeah, now it's not good anymore. Great. Do I have anything lying around? 11's not 13. 1, 4, 6. 1, 2. Okay, so 2 is still failing. Let's figure that out about. If I plus 1 not equal 2, continue. Okay, why you fail me now, 2? So we have our lovely first one. We're passing 1, 2, 3, 4 to 1 and 4. 1, 1, 2, 3, 4, 4. 2, 3, 4, 4. 2 versus 4. Left side is smaller. Oh, wait. You did a... Wait, 2 versus 4. Left side is smaller. Inputs are in right order. Left, right. 2, 4. If left... Yeah, left side is smaller. When you instantly return? Oh, if they're equal, continue. Okay, I see the logic. If left triple equals right, then index plus plus, continue. If left less than right, so then now it's returning this. Return left less than right. I guess. We'll find out. 2 is in the equation, so let's see if that does what we want. Unexpected end of JSON. Did I not do some trimming? Oh, you're the problem. Data! Oh, what are you doing? Get back in there, darn you. Oh, yeah, this is fun. Wait a minute, where's my new line delimited? Do my new lines. Show me new lines. Okay, search in this file. Regex, I guess. New line. Wait a minute. Oh, no, input. You did it to me, didn't you? I bet you did. Firefox. How dare you? Who do you think you are? Ah, you did it again, Firefox. Don't. Don't. No. Stop. 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 Stop it. Stop it. Stop it. Come on. Come on. Give me the curl. Just give curl. Give curl. Come on. Okay, and I'm gonna have to. Eh. Come on. There we go. Gotta swap this real quick because my input got absolutely trashed. Darn it. Ah, can't get the response. Okay, copy this one. No, not that file. Man, I'm literally losing. Darn it. Fine, we'll open Vim up since we can't handle it in VS Code. Oh, how many lines are here? Okay, great. Only 450. Come on, you. Quokka. Go Quokka. Unexpected token, you piece. Well, we can turn this back on as we fight to the death. Get this thing to work. Unexpected token, US, and JSON. There, finally. I'm not looking forward to part 2, that's for sure. Ooh, not the right answer. Tough one. That's not good, because it actually is working for this. Drop some of these. Drop these. Drop these. Drop all of these. Oh, yeah. No wonder it goes slow. So what I said is if they're like this, then they're bad. What if I just do the opposite check? If right greater than left, return false. Otherwise, maybe we can keep going if they're not. No, 21's not equal 13. 1093, not the input. Interesting. Okay, so let's go through it again. If they're both numbers, basically I want to do a comparator. Oh, I'm probably gonna have to do this for part 2 too. Yeah. Tough, tough, tough one. So if they're both numbers, if left equals right, then they're both the same. Otherwise, well, that's actually if the left equals right, they turn. Ooh, return if they're no, we don't. We keep going if they're the same. Hmm. Keep track of all the ones that are good. Yeah. Okay, interesting. Maybe my mutation of the data is what is not liking it. Instead of doing this, we're just gonna. Yeah, we'll do it like this. So, if else, like this. So, if left is number, then we are passing left as an array. Otherwise, if right is number, we're passing right as an array. Congratulations. You like that? 1093. Well, it's thinking thoughts. Love a good thinker. So now I'm not mutating the original data underneath. But we had an infinite loop, so that's not good. Interesting, interesting, interesting. Not liking that one. Ah, this is part one. What's part two gonna be? Oof. Ah. Maybe I need to go to the lengths first. Okay, well this obviously is not working. I made an infinite loop somehow. Yeah, great. Okay, get back to there. Now why aren't you working? Well, I didn't break anything too recent. Yeah, that's where I left it. Hey, it's right where I left it. Okay, there we go. So lovely comparison. Yeah, so let's make a simpler compare. Function compare A, B, and then basically if they're both numbers, if type of A triple equals number and type of B triple equals number, then we have to return something. A greater than B, false, or a, oh, thank you, undefined. I guess for undefined I keep moving forward or whatever. Now the fun one, else if type of a triple, so basically if they're both arrays, well, come on, get type of in here. Technically if they're objects, whatever. B is an object, then, well, this is the part where we do the comparison, the looping, right? So for let I 0 I less than the largest length, I suppose. And then that doesn't seem too wrong. If undefined, if not undefined, return result. Yeah, that seems right. Otherwise, return undefined. Sure. Give me an auto format. Thank you. I don't know about this. Turn undefined unconditionally. We still got to do other stuff. We have to do the length checks. So I guess we could just cheat length less than b dot length. No, if it's greater, then return false. If length is less than b dot length, return true. And finally, I just rewrote that turn A, but we here now. Result has whatever, yeah, boolean or number. Get over it. Array is array A. So hopefully TypeScript will be cool about this. Now boolean or undefined, aren't you? There we go. Hopefully everyone's cool. We have lengths. Okay, you're not cool. Okay, I think the comparison now, if I try and use this, oh wait, we need another one. No, we need to handle the swapping them to numbers or whatever. So, I mean, I don't even need to else it. Say, return compare array is array A. So if A is an array, then it's already A. Or array ties A. Do the same for B. Thank you, sir. That should be right. Now I get to use my cool compare function instead of in right order. Where do I use my new cool compare function? Basically, I need to loop through the packets. These data lines would be like, hey, you good? Data's not defined. Why you, what have I broken? I haven't broken anything. Too many curlies. Get formatted. Nope, nope, nope. Put that one back. Too many up here. There we go. Auto format. Thank you. So I guess here I'll do the sort. Or I'll use the compare. So, but hey, if you're good, then good. Now why you don't want to run? Okay. Great. Hit an error. We're not running this anymore. Not running all this. We love that. Oh, great. Maximum call stack exceeded. Result equals compare I, compare B. Don't see. So if they're both arrays, then they're good. Well, they're not good, apparently. Let's close that one out. Yep, close yourself out. Interesting. So if they're both numbers, they're good. If they're both arrays, they do the length thing. Then if they're not both arrays, then you'll make one an array. What am I getting as A and B then? Like, makes you so angry. Maximum call. Okay, I get that. Can you... We'll turn out the debugger on you. Oh. Come here. Let's figure out where I went wrong. Come on. Come on. Come on. Finally. Okay, yep, A and B, they look great. A and B are ones, they look great. Another pair of ones, pair of 3 and 5. 2 arrays, yep, array of 1, array of the 1, 4. 1 versus 1, we'll come back to 1, 1. Good job. 2, 3, 4, and 4. We'll spin out 2. There you go. 9, 8. Okay, I just gotta find where we get stuck, apparently. Lots of 4s. 4 undefined. You failed. An array of undefined. Up here it is. Okay, so let's step up, back up the stack. Solve 1. Here we go. Which one are we on? 4, 4, and 4, 4, 4. Set me a new breakpoint there. Let's start from the top. Oh, not this one. Get rid of that one. There we go. Love you. You're fine. You're fine. You're the problem child. Okay, so we have A and B, lovely arrays. You're not both numbers, but you are both arrays. So you're going to go through the largest length you got, which is the one on the right. Congratulations. And then you're going to access the index. Easy. Both 2 arrays of 4s. We love that. So your arrays, again, congratulations. Go on in. A length of 2. 2 4s. Result is undefined because they're equal. Okay. So you're going to go to the next 2 4s. Index 1. Good. Your result's going to be boring because you're both 4s. Congratulations. You're boring. Then you're done, so you're gonna do some length checks. Hey, who's bigger? Okay, great. No length is bigger, so you're boring. You're back to undefined. Correct. Now index is 1. You're on a 4. What happens if they're both? One of these things are undefined. I think I'm seeing the issue here. Put a breakpoint here. 2, 0, 1, 2. Index of 3. Here it comes. Index of 3. Congratulations. I'm not doing the undefined check. So if they're both numbers, that's failing. Otherwise, they're both here. Nope. Else. Aha. This is my problem. Huh. So I'm doing an array check, and I'm putting it in an array no matter what, which is false, so it becomes an array of things. So this is supposed to be the length check. Oh, I didn't do the length check because I did the max. I less than a length, and I less than less than b length. There we go. We don't do that. And now our length checks will actually do their job, because I did not do it the old way. Back to 1113. Who's the blame? Good. 146. It should be 1246. So 2 is failing. If I plus 1 not equal 2, get out of here. Great. Okay, what's your problem? 2. Go through 1 to 1, 1 to 4, 2, 3, 4, 4. I feel like I've already fought this one before. But we have an array and a number. So let's see. Well, if they're both... Ah, there's my double and. There it is. Good, made it. Drop that one. Bigger number. Okay, the fun part for part 2. Here we come. Ah, okay. Tough one, tough one. For all your packets, disregard the blank lines. The distress also require... Oh, great. Wait. Putting the packets in the correct order. Wait, what? Oh. Oh, okay. So I have to actually sort these things. Okay, so for this one, I guess it's 140 or whatever that means. I did not actually think I'd be sorting. I mean, I talked about it a little bit, but I was like, oh, great, we can sort this. But now we actually are. Okay, I'm not seeing... Do I have to use an actual? Oh, so I can use dot sort, right? Oh, okay. I sort them. I can use a dot sort. Yeah, so I get rid of the new lines, so we solve 1. And then figure out what this middle thingy is. Okay, I think I can see it. I can see it now. No, so my compare is still logical. I just need to... I don't even need to numericize it, to be honest. So I need to, instead of doing all this split, I need to say, I guess, const packets equals... Yes, we got 6, and then we got 9 joining the party. 2 and 6, never mind. Then we got the rest of them. Dot 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 beta dot split all the new lines. And map like so. Welcome to the party. And then we can sort A, B, const result equals pair A, B. Now if I have to return the number. I mean, I can just return one or the other, right? So if results undefined, congratulations. Otherwise, it's going to be one way or the other. Now, what I have to do, what I want to do, find the decoder key, indexes of the 2 divider packets, and multiply them together. Okay, I can do that. Find index of this one, find index of other one. Okay. Multiply index together, so return packets, find index, p dot json dot stringify, p triple equals json dot stringify, dot 2, and, oh, unless I'm going to multiply it by the other one. So this here, multiply. Did you figure that one out, Copilot? Great. Unexpected end of JSON. Data.trim. Split map. Great. Someone's being angry. Console log raw. See who is failing us this lovely hour. Any moment. You can run now. Oh wait, who's running? Logging. Drop that. Got any logs up here? Drop these. Oh, there's one. There you go, empty string. Okay, I thought I trimmed them all out. Apparently not. I'll have to filter out the blank ones. There we go. Map L L L dot trim dot filter boolean. Goodbye. Now this will work. 144 is not 140. Uh-oh, it's either my indexes are wrong or the order is wrong. We're about to find out. Okay, it's gonna be a read. 1 1 1 1 1 and then 2 more ones. Then you got 1 4 and you got 2. 1 4 and you got 2. Good. Then after 2, so where's 9? 9 is second to last? Or where's 6 rather? Where'd 6 go? I didn't put a 6, I put a 9. Dang, I typoed that again. I got. Now it's 117. Great. Are the numbers 2 and 6? Okay, figure that much out. Well, there's 2. There's 6. 1, 2, 3, 4. 4 from the bottom. Right. Oh, 10th and 14. I mean, let's just log these, I guess. 9. Oh, great, plus 1s. I know how math works. Yeah, come on, get in there. Get in there. I'm gonna do a 1 plus. That'll math me. Yes, big input, big input. I think I got it, folks. Okay. Again, a little tough one, but made it through. Math. Oh, gotta make sure your rules are working right, folks. Oh, okay. Still top 2. With that, it's time for our first commit. And yeah, a lot of this, seeing already. Fair amount of good polishing up here. Tat script solution. That input coming in bad really messed me up. Because what happened was my browser was like, oh, this is JSON. I'll parse it. But then it wasn't to be parsed like that. So I copied in bad there. This is definitely going to encourage me to get my script ready and ready to download stuff. As first optimization is to extract this compare function. Now that I know I'm actually returning numbers, which ways false go? Yeah, so true is -1, false is 1. Yeah, so I want, if true, -1. Replace all trues with -1s. No, that's actually not that easy. Replace all falses with 1s. Replace all undefineds with 0s. Lovely. So this returns -1 or 0 or 1. Lovely. We're also going to check this one around to say, hey, if you're both not arrays, do the thing here so we can reduce indentation here. Loving that. And then this, I happen to use this comparison. I think I'll go back to my undefined checks, to be honest. So this will basically be const. Yeah, I'll swap it back to my while loop because I liked it. While true, and that'll basically be let AV equals while plus plus I plus plus. I don't think I'll go for a do while. Do while I plus plus. I equals 0. You know, I think a for loop is actually appropriate here. And we'll say end equals math.max a.length b dot length, so we can only compute this the first time. Here comes the fun part. If a I equals undefined, which means a length is less than b length, correct. Then if not 0, return that. Correct. Got too many curlies apparently. And loving that. Great, I broke it. Because I'm not loving that. Maybe I flip these. Oh, tell me that doesn't change anything. Okay, let's time travel a little bit. That was too many changes. Too many changes, jeez. What have I changed? Oh, I changed the numbers, yep. All the way forward, so if triple equals 1. -1? 0. If doesn't equal -1. Doesn't equal 1. Because I did break it. Not just the numbers. Okay, so we're gonna swap these back to any. Swap this down to true. Swap the zeros back for undefined. The ones for falses. -1s for trues. Nope. 15 is not equal 13. Well, shucks. Great, let's do the length checks down here. Okay, that makes it work. So why can't I do the trick here? If a length is greater than b length, aka if b is undefined. Well, I flipped it, didn't I? Come here, you. There you go. Maybe that was it. Okay, looking good. Nice. Okay, that was the issue, which means I can flip these back to numbers. Because if a is greater than b, then my false, so I need to use it down here, is 1. My true is -1. My 0 is undefined. Now this, I just need to say not equal 0. 1. -1. I only want truthy, so maybe I want 1. 0. All I'm changing is this. Huh. Don't see why I can't. Oh, I forgot a 0. Get in there. Okay, maybe I don't care about this as much as I thought. I'll put the symbols back. There we go. Good enough. Okay, now I get to use this compare. First, let's do this one. So for this line split, good. And we'll do a spread parse. Hopefully it's cool like that. It is in fact not cool like that. And this is good. We can make this a sum instead. Sum equals 0. Sum plus this. Then return the sum. We can do that math. Easy. Okay, part 2. Hello, compare. Goodbye, compare. Nothing breaks. Glad to hear it. I guess we'll flip the Boolean and flip it to a number. Or not. Leave the Boolean. Because we're... Yeah. Okay, I think this is pretty good for packets. So we have to sort and find the index of the one we inserted. Bit hard coding, but it works. We can optimize it though. Okay, we can make this ternary. Return result. Result. If there's a result value, no. Return result triple equals undefined. Thank you, or result, whichever number you choose. Still need this variable. We can definitely cache these or memorize them. We are fine as is. His stringifies are not good. We'll make an extra packets thing. Extra packets. You are an array of any's. Yep, we're doing great TypeScript. So make a function here. Function short and what's this? What are we calling this thing? Nope, don't resend. Don't go back. The other way. Hey, Jack Tree coding. Not in the top 100. Not this year. It's not that easy, unfortunately. I am in the top thousands or so this year, at least. You gotta go to the previous years to see me on the public leaderboard. Well, thanks for coming on by. Yeah, the closest I've made this year was day 7, 122. So if you're not top 100, you're not publicly searchable. I'm sure I'll get there sometime this year. Only get there about like 1 or 2 problems a year. Because it is competitive. Decoder key for the distress signal. Okay. Calculate. Decoder key. This is where the extra packets go. Da-da-da-do. Nah, it's all good, Jack Tree. Yeah, of course. I mean, I think if, I think there's a private leaderboard that the fellow 100 devers are all on, and that one you can see everyone there. Trying to figure out who. It's one of these. I don't remember which one it was. Nope, don't recognize these names. It's one of them. Nah, I don't recognize these names. Yeah, this one might be the 100 devs one. Maybe. I think it's that one. Oh no, this is the 100 devs one. Yeah, there's Motherboard. I had a Code Wars warrior themselves. At least on this one, you can see everyone on the thing. And if you have the extensions installed, you see the cool graphs. Lots of graphs. Yeah, there's Motherboard. Only up to 10th. But yeah, pretty fun nonetheless. So I think this code needs to go in that code. Boop. Bop. Extra packets go here. And then we need to return packets, reduce product. packet. Figure this out. Product time 1 plus their index. Perfect. Well, not perfect enough apparently. Until I call it. For sure, Jack Tree. Yeah, these recent days have picked up in difficulty, but even without that, it's fun to see the different data structures and stuff and look at the solutions afterward, just like Code Wars. Delete that. First extra packet is 2. Extra packet is 6. Why are you angry? Okay, so some kind of weird data structure. You're weird. Number in a packet isn't any. There we go. Something. We can drop these parsing. There we go. All our packets lovelily sorted. Can be cached, so we're not going to. Drop that, drop that. And that seems good in my book. If they're numbers, if they're both not arrays, else do my lovely loops. Solve 1. Yeah, that does seem to be up. What's this? Solve 2 doesn't take extra packets. It passes extra packets. There we go. Now, as for this one, how the heck would we visualize this? Hey, of course, Jack Tree. I appreciate you coming on by. And yeah, feel free. Get some good rest. Lots of cool things to do tomorrow and such, right? Appreciate you coming by. So I guess what my visualization would do, it would be kind of a vertical visualization like this, and it would go through it like this, and it would prettily format some of these. Boop, like that. So then once it got to anything that failed, it would somehow make one of them turn red, one of them turn green, somewhere pointing to where it went bad. It would be expanding it at the least. It'd be a tough one to visualize. Lots of ASCII manipulation, but I think we would be able to manage it under the queue of other visualizations. 2013 TapScript solution. Loving that. Very cool. Let us check it out. Let's see if there are any cool ways we could have done this. A lot of memes this year. Okay, let's check. Oh, let's flip that one out. If JSON loads, that's what we all did. TypeScript JSON parse, right? Compare that can be dropped into sort. I didn't really write it that way, but my problem was the compare itself, and I didn't even get to the sort. Thanks for scrolling. Someone wrote bubble freaking sort. Wow. Hub func tools comparison to key function. I remember those. No lift, man, you're still going crazy. Comparison backwards, sort has reverse. That's cool. More Python, comparative function in Python. Okay, everyone, we love Python. We love you. Come on. JavaScript. We got one, folks. And the TypeScript. 10.5. How the heck did you... Whew. Okay, one, they parsed it. Oh, they just literally, okay, that's cool. Compare eval. Oh, I didn't think of that. Compare A and B, and then two. Oh, not too different. And the sort. I didn't realize undefined wasn't bad. Oh, would you look at that? Yeah, same number. My array's backward. They went for the length. Oh, there's my +1. Yeah, mine's prefix. And they came up with this quick. He's got the JavaScript. Yep, this is my first one. Just that is integer instead of type of. Index greater than right length. Okay, that's an easy way of returning it. Packets don't match 0. Yeah, it looks like just writing that freaking sort. Oh, that's right. If you keep the same object in memory, I could have done index of. Neat. And very similar, similar to my first approach. And then the length is 0. Okay. Compare functions. Ooh, my word. Split, map, group, flat, concat, sort, all the fun stuff, and everyone used the cool index of memory based. Yeah, so it looks like nothing too crazy JavaScript wise. There was either the wrap it up in arrays and let the magic handle the rest of it, or recursively call ourselves on them. And everyone went with JSON or eval as expected. Yeah, that was a pretty good one, folks. Looking forward to... Not really looking forward to visualizing that one. Gonna be honest, it's gonna be the ones I will attempt to skip. So yeah. With that, let me go ahead and push away. There it is. Repo fully synced. And with that, we will call it VS Code. Come on, VS Code. Come on, VS Code. Quokka must still be trying to do stuff. But there you go. Goodbye, Quokka. And with that, we will call it a stream. Yeah. Catch you tomorrow. Toodles.